So my presentation is titled Target Application Platform. My name is AVALOS. I'm a lead engineer at Target, and I lead specifically, we go by Team Tacos, but we deploy Spinnaker in many different forms to manage all of our different platforms. And so I'll be telling the story of our path from Chef to immutable infrastructure, and then finally to Spinnaker and Target for the last year and a half now. So background information, if you're not familiar with Target, which not everybody is from the United States here. So it was a company founded 55 years ago. So you'll probably recognize like the large Target storefronts, but we also have these smaller format stores. This is actually my local store. It's in downtown Minneapolis. We have really renovated like markets, which I think is really cool to see. This was like the main picture that we used. But I see that every single day. And we have 1,800 of these stores all across the United States. We have 323,000 employees nationwide. And I think we have about 10 to 15,000 employees just in Target Technology Services. And then we have 39 distribution centers. So to give us a little bit of background where we were 2 years ago when I started at Target, my first week at Target was doing chef training, and luckily I did not have to use so much of that knowledge. We ended up, Target chose Chef as the standard configuration language for all application teams as well as the infrastructure teams. So we were creating a base image product using the Chef process. Application teams were then layering their Chef cookbooks on top of our base image and creating what ended up being what I consider a mess. And Chef is great when you need it to do like one little thing a few thousand times maybe, but when you really get down to it, we were creating a base image and we weren't updating it too often for depending on a Yum update run by a Chef cookbook to update that base image on every single converge. If you really think about that, the horror story that I tell people is that it took us 45 minutes to converge our Jenkins server. This was a factor of downloading all the Jenkins plugins, restarting our Jenkins servers multiple times in our Chef cookbook process. We had about 1,800 webhooks that we had to register on every single startup. And so it was an ugly story. And that was one of the motivations for me wanting to kill Jenkins at Target specifically. So I can talk about that later, but yeah, so as cookbooks aged, we found that they built up a lot of cruft. They would increase the converging times. A lot of the app teams were not very confident in their cookbooks converging on a later date, maybe after a month or two. And so this was really a problem that Chef has tried to solve. It as Chef Zero, where you have all your dependencies locally. But even then, that would have required a complete change of our release process and what deployment tool we were using. So you can see where I'm leading up to here. Yeah, so teams got into the habit of also manually scaling the machines because they are taking so long to converge. So an example is that we know when our website is most on demand around Black Friday. So teams would then scale up their server groups and then scale back down manually instead of letting scaling groups do this for them. And so it's just creating habits that I would consider great. And then you always had the chance that people forgot to scale down their server groups later. So why did Target choose Spinnaker, or why it chose it? I always get confused which one I'm supposed to put there. English is my second language, so I use that as an excuse. But we were looking at a bunch of replacement tools. And so the replacement tools that we were looking at the time were, where did I write these down? There's a lot of things. OneOps, Cloudify, Cloud Foundry, and OpenShift. And so we were looking at all these tools and trying to find one that was the silver bullet. We think Spinnaker checked off as many of the boxes as we possibly could. And what it really was giving us was a story of immutable infrastructure. We had groups that were realizing that their converges were very Tippy. It was easy to break it if upstream changed their URL path for a dependency within their Chef cookbook didn't converge, then they had to go in and modify code. So the teams that were high performing were already using Chef Zero or a process similar to Chef Zero where they would take a snapshot of a volume and deploy that. So this really gave us the pattern of immutable infrastructure. You can scale in seconds, you can scale in minutes versus the 30 minutes that it takes for your systems. All of our dependencies were baked in, so we no longer had runtime dependencies apart from console and Vault. We had all of our dependencies baked into a machine image. The other big reason that we picked it, of course, is because it's multiple cloud provider support. The big thing at Target is that we have a multi-cloud strategy. And so we're really trying to avoid vendor lock-in. And the way that we do that is by employing the use of a lot of open source software. We'd rather contribute and use open source software than to pay a vendor whatever fees they would have to run something for us. And so, like, for example, if you're in GCP, you don't necessarily want to use the services that will stick you in GCP for long term. And I'll talk about a migration that we did last year. Extensibility at its core. So I think since I started using Spinnaker, K8's DCOS and a few other cloud providers have been added. Like, I keep joking that every single time there's a new cloud provider added, oh, we should switch to that platform because I can already probably configure it. And so, like, with DCOS announcing that they had Kubernetes available, I was just like, well, we could probably switch to that and be the other reason that we really like Spinnaker, and I think a lot of people are slowly realizing this, is that the pipeline engine is very powerful. You do everything that you really need. And I think Guard's presentation where he mentions that they have the post staging and post-prod or something like that, like, I want to emulate that. And like, people are doing really cool things with the pipeline engine that we should get out into the greater community, but also it gives app teams more power over what they're doing. And I guess I can briefly talk about what our old tool was. We had developed an internal tool. It was known as Houston. The idea was that it eventually would have pipelines, so Houston felt country. And we actually finally got to the stage where Houston was mature enough that we started implementing pipelines, but we found that users were having a really hard time writing out complex JSON files that just were very finicky. And so Spinnaker gives you that GUI for a lot of people. Like, we're trying to build the tool that 90% of people can use, but maybe the 10% power users or the 5% on either side that need a little bit more help, or people who are power users. We have a group at Target that uses Spinnaker to deploy Mesosphere and then runs their native jars within Mesosphere. Brief note about the OpenStack driver. So last year and a half ago, our managers from Veritas and Target realized that we both wanted an OpenStack driver. And so they reached out to each other. They had a few conference calls, and then I think it took about 6 months to get the OpenStack driver completed within there. Our little spiel about it is that we built out the POC for an OpenStack environment last year during our peak season, so that was in 2016. We took production traffic with a pattern that emulated our previous cloud infrastructure, so we were able to deploy our console, our Vault, our Factory servers into this POC, and more or less gave people the exact same experience for that single application team. So that application team was able to take production traffic on the platform we brought up fairly quickly in less than 3 months. This is where I think we need to spend a little bit more time talking about, is that establishing a pattern is very important for Spinnaker adoption, especially at a large company like Target. Like talking to people here, I've started to realize, oh, lots of people are doing really complicated things with the API, but they're also not doing it at the scale that Target has to be doing it. And so we've actually spent the last mostly year and a half teaching users about immutable infrastructure, about how do you use this pipeline to bake and then deploy and connect to an ELB. And so there's been a lot of user education and sure, managed pipelines and declarative pipelines are a great tool for super users, but a lot of the users don't necessarily need them. So somebody brought up in the last talk, it's like, how often are you actually fiddling with your pipeline? Like, once you've figured out your pattern, you're maybe going to change a load balancer once or twice a year, but it's been something that we've wanted to work on for so long, but it's always moved down our priority list of features that we needed to actually get there. The other thing that we realized actually pushes a lot of our adoption is creating a base image product. And so building all of our services into a base image, and then having Council, Vault, our logging stack, our metric stack, all built into this base image means that teams are actually enticed to come to Spinnaker and stop using our old Houston platform. One thing that we never really got the sign off on was turn off Houston. We let teams use Houston up until about 2 weeks ago when we finally turned it off. And now all of Target either uses Spinnaker or uses Kubernetes. And so target.com is 50% deployed by Kubernetes at the moment. And I think that's just like, you create these patterns that like really gets people enticed into moving over to your stuff. And so what I think Kubernetes really does is like, it's abstracted a lot of your problems away. And I think the one that people really love from application team perspective is Prometheus. And so like, that's not like a first class thing in Kubernetes, but lots of people run Prometheus for their metric stack. And so being able to use that has gotten a lot of teams to switch over because they're like, oh, wow, you can get that for free. One thing that we also realized is that our cookbooks were also bad citizens, as in they were taking forever to converge. And so we had to establish a pattern of how do you take your cookbook and create an RPM or temp out of it. We chose RPMs, and we ended up basing a Target RPM plugin based on Nebula that had a little bit more Target opinions about how RPM should be created. And thankfully that we only had to support one OS, which is Sentinel 7 instead of a couple of different OSs. So that really helped in just making sure that users are able to come over to our platform as easy as possible, and that we made it so good that my favorite example is a team really didn't like being within our own accounts. And so they asked, oh, can we have a set of our own accounts? We'll stand up everything by ourselves. That lasted about a week, and they came back. They came back and realized, oh, wait, the base image is actually something that we need. Oh, wait, you have Spinnaker there. Like, we use Spinnaker to deploy Mesosphere. So it's just like, it was very nice to feel needed at that. Yep. Let's do it. Our CSP migration. So over the course of the last 8 months, so up until 2 weeks ago, we actually moved from our previous cloud provider to GCP. And so it really was only about a month's work of moving our platform components, so Console, Vault. We have an internal service called Trust Me that does identity management, and a few other tools that we had written for the old cloud provider. We modified slightly for a proof of concept in OpenStack, and then tweaked ever so slightly to get it into GCP. So we were able to provide our platform right away, and we actually broke down, I think, at least 80 application teams into waves. And each of those waves was able to move their stacks over to GCP. Then once they were there, any service that had them as a dependency could move over to GCP. And we slowly just built up momentum there that it snowballed into moving to GCP.
Do you also run some things in the store? Or?
Yeah, I'll talk about that with the tap slides. And so the teaser for that is that we're going to be running Kubernetes in all the stores.
Was there anything else in terms of that migration that you used from AWS, so in terms of like databases or anything that you needed on Google?
Oh, we do not comment on which cloud provider we came from. And so there was, so the whole purpose of being in the cloud is that we basically want to use it as a scaling platform and not necessarily as a solutions platform. And so anything that would be platform specific, like a database as a service, our whole policy was if you can't migrate it from it within 4 weeks, don't use it. So none of our teams are actually integrated into a cloud provider service heavily enough to need to re-architect heavily. And so we actually have service teams that offer Kafka as a service, Cassandra as a service, metrics and telemetry and logging as separate services. And those are all built into our base image. And once they converted to GCP, we were able to just bring them up. And what we really liked Spinnaker for was that, like, when you really break it down, Spinnaker broke up our deployments into the idea of server groups, load balancers, and security groups. That translates to almost every single cloud provider within Spinnaker right now, and it's very pretty. And teams didn't have to relearn everything that was specific to GCP to get it in there. We're actually we're moving from another vendor into our internal cloud provider, which is OpenStack stuff. And we're actually not seeing as many hard difficulties as we did with like the size of the GCP migration. So our OpenStack migration from the previous vendor is now, it's going pretty well. Like, we were able to get our platform stood up in a month and a half in OpenStack this time, and teams are going to be starting to use that platform over the next couple of months. So this brings us to the Target application platform. So this is our little mascot for the Target API, or the TAP API. So it's a recursive acronym. So it's the Target Application Platform API. And so we call it TAPI for short. And so he's my favorite little guy because this is where we're extending Spinnaker specifically in such a way that it is very target. And so there are portions of it that I would love to see open sourced, and I'm fairly certain if we twist enough arms that we can open source the frameworks for it. But it really, at its core, is a set of Kubernetes controllers that you can provide Kubernetes manifest to describe any resource that Spinnaker might not provide. And so a great example of this is DNS and buckets. And I know there's some DNS code within the AWS provider, but like there isn't that for the GCP provider, there isn't that for the OpenStack provider. And so what we end up wanting to do is create these Kubernetes controllers that give us the desired state of our infrastructure. One pattern that grew out of moving to immutable infrastructure is that we started using a lot of Terraform. And we ended up making a lot of repositories that were on this pull request model. And a lot of application teams would open up a pull request on our repos that created infrastructure for them. And then they would have to ping us, and then we'd have to review the PR, and then merge the PR, wait for the Terraform to run. And we just found it to be a huge drag, and the application teams became slightly resentful about that. And so really what we're building out in the TAP is the idea that you can have an API that the users use and that we build in all of our best practices in, and we don't have to be approving pull requests constantly. We're also building it in such a way that it's a framework where if our security team requires adding more security features to, for example, a bucket in GCP, they can add code that then adds ACLs to the bucket. And so teams, next time that their API call runs, would have their buckets migrated to the new format. And this, with the Target application platform, there's always been a large discussion of how much do you abstract away from your application teams? And how much do you want them to actually know what hardware they're running on? And because in my mind, like if you're a full stack developer, like you know about your OS and you also know about your front end, and like the truly full stack developer. And in my mind, like I've started to be talked down about this, and in my mind, it's the application teams really just need to be able to deliver their features. And so at Target, we're really about trying to get to production as quickly as possible. And this is where giving the users control over their infrastructure TAP-wise is the best approach for us, which depends. Like where Target is not like other big companies, but it also is very similar to a lot of big companies. And you find a lot of commonality, especially the Spinnaker survey. If you will see the results at some point, you'll see that everybody has the same problems over and over again. So where does Spinnaker fit into this is basically this is the diagram of how Target works digitally. And so these are in very generic terms though, but we're going to have an API sitting at the top here. We already have the API integrated with parts of Spinnaker. We have the API built integrated with parts of Drone, which is our Jenkins replacement. Drone is it's an open source tool. It basically uses Docker containers to run your pipeline steps. It's pretty cool. I highly recommend you use it. We have a little Drone plugin that launches Spinnaker. So here, these are all these services that we build into our base image that other teams can just plug into right away. And so the idea is that we will provision these resources for teams via the API. So they'll get access to our API gateway, they'll get access to our logs, metrics, and everything that makes up our telemetry stack, as well as our database as a service, so Cassandra or MySQL if you need it, and then also our data as a service layer. And all of these are actually, they're all deployed by Spinnaker, which is really cool. And I know some people have problems doing things with persistent storage within Spinnaker. Somehow our teams figured it out. I'm not privy to much of the details, but they deploy Kafka and they deploy Cassandra using Spinnaker. And so in our external clouds, we currently offer the 2 runtime environments of K8s and virtual machines. We do that, we're planning on doing that within our data centers, but what we're going to be trying to do over the course of the next 3 years as hardware is upgraded within our stores and our distribution centers, is that we're going to be running and dependent on Kubernetes within our data centers. And so what Target does there is that we have a custom cloud driver that can deploy into the stores as a unit, basically. And then everything down here, I don't really care about, in my opinion. That's somebody else's problem. But like, this is my group's problem. And so we get to figure out how to do this over the course of the next year. And so we've made some really good progress with getting native API access to Spinnaker instead of doing SAML authentication, being able to launch pipelines within Drone, and then setting it up so that we can launch pipelines using any build tool is one of our goals ultimately. And also working with Google and consulting a lot with Netflix to figure out like, what are the common problems? How do, like, we're large companies, how do we solve this for everybody? And so that's why I'm here, and I'm hoping to share a lot of ideas with others.
Quick question, what are you using for your API gateway?
API gateway, it's all homegrown.
Or homegrown?
Yep. I think it recently got rewritten into Go, and it's like, it's really cool the way that they do it. And we actually, our API actually plugs into the API gateway. And so there's some weird interdependencies, but it's okay.
Can you speak to why, see you guys are moving away from Jenkins? A little bit make it out like the equation,
Yeah, so Jenkins, when I jokingly call it Jenkins because it was so janky, we lost all of our subject matter experts with so how our Jenkins server was configured. It got dropped into my lap, and so I didn't really want to learn the Jenkins DSL. And there was people at Target that were starting to experiment with Drone, and we noticed that developers really loved Drone. Specifically, they were able to define their pipelines right in their repo and have a running job within 2 minutes instead of having to go into Jenkins DSL and modify a few different settings. And they were able to move over very quickly. And so, like, one little example that I really like is that I have this job that can create all of my internal Hel containers or Halyard containers with pretty simple code. Like, this is all, that's the whole process. It's basically just take these versions of all these containers and build them. And like, that seems a lot more readable than Jenkins DSL, for example. And like, app teams love that. And they're able to just launch into The red is the container that doesn't actually exist. Speaking of which, I need to figure out why it doesn't exist. But for example, like this does all these containers in parallel and loads them all within like 3 minutes and pushes them up. And it's pretty cool the way that it works. So does that answer your question?
Yeah, and then you guys also use drones for testing and artifact.
Yep. So there's a certain service that we have like a PagerDuty clone, and that's it does end-to-end testing of all of its alerting, and so it does it through drone. It's just running Docker containers, and so if you can write your job in a Docker container, you can run it as a drone job, and that really gets you away from a lot of the dependencies.
Can you show the Spinnaker integration that you have then?
Yeah. The URL. Yeah, so we have a simple Go program. So the main way that it's supported within drone itself is that you just call Go binary, and this looks a lot like Docker Compose templating. It is Docker Compose basically under the hood. And you just feed the program your flags, and we're able to point to Harbor Master, which is our certificate service for X509, and then which gate server that we want to be talking to, and then, for example, which pipeline you want to trigger. And so it's providing that much information. Ideally, we're going to define arbitrary amounts of information and use that to trigger pipelines or arguments for pipelines.
And that's not open source.
Harbor Master will be, well, so this one is not, I think we're probably going to be, this I will try and get open source. There's nothing proprietary in it. Harbor Master will be open sourced hopefully by the end of this month is my goal. And then we are going to be contributing how we do X509 certificates at Target now this week, maybe today. We'll see how they go. Any questions about those? The one weird thing is that I think all the other build tools do a poll model for triggering Spinnaker pipelines. Drone does not really support that, and so what we end up doing is a push up to Git to trigger pipelines instead of just watching Git for changes. Yeah, so future-wise, I feel like I had a list of requests. We like this idea of the Simian army, and we're kind of sad that most of the Simian army is like not Go compatible and Spinnaker compatible. So we're thinking that like maybe Janitor Monkey can make an appearance again and have Spinnaker integrations, but that means also extending Spinnaker to clean up AMIs. For example, or like, what are they called? Just images. And then OpenStack, they're also just images and stuff like that. So building that into all the cloud drivers would probably be nice. I also think that, yeah, just generally sharing your ideas and like maybe doing an idea board or issue, like whenever I have a thing that I want in Spinnaker, I usually will try and open an issue and see if other people comment on it. And what we've been doing with Google is that Google has been opening up their Google Docs with their specs for new versions of certain features. And so I think getting more open about that process and soliciting feedback from larger companies, even smaller companies, because like we all do have the same problems. And so getting a lot more community involvement in that. And in my mind, I kind of want to see like a central like example template with DCD defined pipelines. And so we can say, oh yeah, this is how we deploy Cassandra at targets, and like give examples of like, this is how the pipeline looks, this is how you do it safely, and this is how you do whatever you need to do for Cassandra. And then this is my contact information if you want to reach out to me. I'm Techmon on Slack, and I try to have my name on everything else. So if you search for me, I'm usually not the soccer player from Spain. Any questions?
You said you had slides about the stores, or is that?
Oh, it's
or
just-
going to tease us.
Yeah.
Was that the store slide?
Yeah, so Kubernetes is it's basically running on some hardware within stores. And so the whole idea there is that stores, it's a great example of hurricanes hitting stores, is that you want to still be able to like keep track of merchandise within disasters. And so we run a lot of hardware locally within stores to be able to do day-to-day business. And so Kubernetes seems to be the way that we're going forward with that. So getting a pattern that we can do a deployable unit in Spinnaker as a store or a group of stores, and then giving it a manifest of the application versions that we want to run, and then getting that.
You use Spinnaker for Kubernetes as well as everything else.
So right now we are waiting until the next version of the Kubernetes cloud driver. This is like another topic of discussion that I have enjoyed with other people here, is that it's very hard to take access back away from users. And so when we started off with our Kubernetes clusters, it wasn't under my team at the time, but teams were given namespace tokens and they can do anything they wanted in that namespace token. And so what that leads is to a lot of people using drone to do a kubectl apply on their deployment YAMLs, for example. And so that pattern is really, really great when you have direct access, and Spinnaker doesn't do that for you right now. And so we've showed the current state of the Kubernetes cloud driver to teams. They're not interested, I think, for a legitimate reason. And so the next version where you can actually import manifests is like pretty compelling to me.
You mentioned that you have a custom cloud driver for the stores. Can you just talk about what the different feature sets are that versus, data?
Yeah, so I don't know too many of the specifics. We didn't write it. It's somebody who is a former Netflix employee, knows how to use Spinnaker very well. And so they wrote that out, but it's how do you logically group stores as a deployment unit, and how do you leverage Kubernetes to behave as like, basically presenting a bunch of Kubernetes clusters as a single Kubernetes cluster. Yep.
Do you do anything with devices? And, like other people are talking about CDNs,
Yep.
store is filled with all sorts of interesting device type stuff.
Yeah, so I think all these stores hit APIs that are located within their stores, and so they'll be driven via these KH deployments. That's the My Device that they have in stores, and so when team members get a question asked about what's this price or price matching and all that kind of stuff, I'll look it up on this. I think it's an Android device nowadays, and that just is a little gateway into our API. Yep.
Any other database as a service? Are you managing that with Spinnaker as well?
Yep. Some teams are using Spinnaker for their database as a service. We have one team that's Cassandra database as a service, and they're using Spinnaker for that. I think they are deploying Cassandra per teams, and so they're managing it that way instead of trying to run one giant cluster for everybody.
So do you build separate build steps just for that, or?
No, so the Cassandra team will go and then launch the Cassandra server for the teams, and the teams just plug in their host name.
Sorry if I missed this. The building the images, is that part of the drone or do you use Spinnaker to do that?
So for Kubernetes, we do all of our container builds within drone. We don't use the bakery options within Spinnaker. But for GCP, for example, we do all of our bakes within GCP, and we're using just a built-in ROSM integration for that.
Did you say you use Prometheus for the logs and stuff?
We use Prometheus for the metrics and a few other telemetry things. And so if you all aren't familiar with Prometheus, it's basically like a centralized metrics gatherer. You write a Prometheus metrics endpoint into your application. You advertise that in your Kubernetes manifest, and then the Prometheus server will start scraping that periodically and then send the data off into really cool visualization for you. And so that's what we're using it for. And lots of teams are seeing the benefit of being able to, I wonder if I can, Yeah, so there's a lot of different libraries to create Prometheus metrics endpoints, but like pretty simple. I wonder if they'll quickly. Oh yeah, so like this is what a Prometheus endpoint looks like. It just displays a simple page with like, if you wanted to define something called process resident memory or something, and then these are the values for that. It's like straight up, that's all you need to write. And your application just keeps updating those counters.
How are you deploying Spinnaker?
So we had 6 Spinnakers as of 2 weeks ago. We now have 4 Spinnakers, and then however many Spinnakers we need to run on our laptops. And so we are currently doing 2 of the Spinnakers via Halyard. All of the Spinnakers on our laptops are deployed via Halyard, which I could probably start right now. But it's pretty cool, like being able to run Spinnaker in Minikube via Halyard just like lets our Tappy team just run all their tests and being able to develop against the API right away. Thank you, Mars. Yeah, it took us a while to finally like say, yes, we'll start using Halyard, and it ended up being a lot less painful than I thought it was going to be. So for example, if you go into, so we use the same script to deploy all of our environments, which in the end ends up being like 344 lines, and like it's pretty powerful what you can do. And so anybody on our team is able to just go in here, run a few scripts, and is able to set up a Spinnaker provider with APIs enabled if they really want to. Any other questions?
I have a question about configuration management. Now you mentioned that you bake all those config, like console boards, all those configs to the base MI.
Yep.
What if there are like some live changes on console KV?
Yeah. So all of our console checks. So when we bake an image, it has a console client built into it. And so the console client has a console token assigned with it. And it's using that console token basically just to watch console for changes. And so once a change occurs, it does it on demand. Like if your service needs to restart, it will restart your service for you. But a lot of the applications will just read the value and be fine. A lot of the time, if they do have console key changes, it's usually going to be with a new deployment and the blue-green namespace within their console keys. Yep.
Yeah, just to go back on the Prometheus discussion. So what kind of stack are you using on top of it? Do you use a time series database and something for graphical?
That is no longer my team and my area of expertise. So like, if you give me your contact information, I can point you to the guy that knows all that here.
Sure.
So you use base images to distribute everything. When you rebuild those base images, are you automatically rebuilding any image that uses those base images as well?
So this is where I kind of wish that there was like a universal stage and a universal like pre-stage and a universal end stage in Spinnaker that was transparent to a user. And what I would do with that feature is basically if there is a new base image released, relaunch every single application. And like that would take a lot of trust in the users trusting that they would let us launch a redeployment of the application with this. But basically right now, if it's something critical, we'll announce it on a list and teams will go in and rebake their images and deploy their application. A lot of the time there isn't something that's super critical. And so next time they deploy, they'll get any of the updates, but we take care in making sure that if there is a breaking change, we tell people, we give them a date in the future that things are going to be broken. Any other questions? I could talk about this for a very long time. A lot of opinion, so hit me up throughout the days. Yeah, I don't think my desktop. I agree.